What I want to do here is reintroduce the tree diagram. Sometimes when we're in seventh grade and we're doing tree diagrams, it is a little bit too abstract. I'm sure that we're going to be just fine with this, especially because we kept the examples pretty simple, pretty small. In many cases, there is more than one action or choice, which results in several outcomes. Tree diagrams are a useful tool to organize and show all the possible outcomes. So the spinner below is spun twice. So the first time that you spin the spinner, you can either get A, B, or C, right? That makes sense that all three of those options are available the first time that you spin the spinner. So a tree diagram can either start at the top and work down, or it can start at the left and work to the right. Those are both equally viable options. So let's say that we start our tree diagram and we do A, B, C. You'll notice that I spread them out a lot so that there's room underneath for the next choices for the second spin. So on the second spin, let's say that we can either get A, B, or C again. Now, I didn't remove anything from the spinner. All three options are still there because if I spin an A, I'm like, yay, I spun an A. What can I spin the next time? Well, I didn't take anything from the spinner, so I can still get A, B, or C on the second spin. If I spun a B, it's still on the spinner. I can get A, B, or C again. And if I spin a C the second time, I can get A, B, or C again. So the sample space is interesting. Most of the time, what you will see is something like AA, comma, right? Because I can spin an A, and then the second time I can spin an A again. I can get AB, spin A, then B, AC, spin an A, then a C. Then I might get BA, BB, BC, and then I might get CA, CB, CC, leaving me with a total of 9 outcomes. So when I look over here, probability questions, the probability that I get B twice. So I want to look at my 9 outcomes in the sample space and say there's only 1 out of 9 that has the B twice. At least 1A. Okay, so that means I would be happy with 1A or I would be happy with 2 A's. So that would be 1, 2, 3, 4, 5. There are 5 options that have at least 1A. So that would be a 5 out of 9 and no C. Like, I'm happy as long as I don't spin a C at any time. That's happened on a game before, right? Where you just want anything but, and you're like, I don't want that thing to come up on the spinner. So you would have no C, no C, no C, no C, and then everything else has a C. So that one would be 4 out of 9. And this is pretty much the same setup for all tree diagrams. So the next one, the popcorn stand offers buttered or unbuttered popcorn in 3 sizes, small, medium, and large. You don't necessarily have to do your tree diagram in the order that the question states. You could start with buttered or unbuttered. You could start with small, medium, or large. That part really is up to you because the results are still going to be the same. So I might do this one small, medium, large, and then buttered or unbuttered. If I buy a small bucket, I might buy buttered or unbuttered. If I buy a medium bucket, I might get buttered or unbuttered. I don't know who gets unbuttered, but whatever. Large, I might get buttered or unbuttered. So now I've got all of my possible outcomes. I can get a small bucket that's buttered. I can get a small bucket that's unbuttered. I can get a medium bucket with butter. I can get a medium bucket unbuttered. I can get a large bucket with butter, and I can get a large bucket unbuttered. And if you're like me, there's only one correct outcome, and that is a large bucket of buttered popcorn so that you have extra to take home. Now, that shows you that there are 6 outcomes. Over here, what's the probability that you get popcorn that's buttered? Now, I don't actually need to use the tree diagram for this one. My options were buttered and unbuttered. I know that it's 1/2. But if I'm using my tree diagram and I'm using my outcomes, buttered is 1, 2, 3 out of 6, which simplifies to 1/2. Large is 2 out of 6. But I could go back here and say, well, there were only 3 choices and large is 1 out of 3. 2/6 also gives me the 1/3. Small with no butter. So if I want small, well, there's small buttered, there's small with no butter. There's only 1 out of the 6. All right, so just wanted to give you a head start on reviewing tree diagrams and some of their, technicalities.